book appointment for information on how to start or to simply get questions answered. Life's Journey Counseling Services has multiple therapists on staff, so your questions, concerns, and counseling needs will all be met. Life'sJourneyCT.com. It's the best place to start your personal journey to heal, become a better version of yourself, and strengthen your relationships. Life's Journey Counseling Services, 70 Main Street here in Jewett City, Life'sJourneyCT.com.
This year, Jewett City Savings Bank is proud to celebrate an incredible milestone: 150 years of helping individuals, families, and businesses succeed. Thank you to our valued customers, employees, neighbors, and community partners for putting your trust in us. We look forward to celebrating with you and to continuing the important mission we started back in 1873 to give every individual a chance to thrive. To join the celebration, visit jcsbank.com. Jewett City Savings Bank, member FDIC, equal housing lender.
The go-to barbershop in Jewett City is Sharp Image on Main Street, located in the same location as the iconic Aramoni's Bakery. It's not a bakery anymore. Ruben and his staff will style you to perfection every time. Sharp Image is always running specials, plus some exclusive deals with some of the future barbers that Ruben is training today. Yeah, he trains them. Find Sharp Image on Facebook or call 860-591-1177. Sharp Image Barbershop in the former Aramoni's Bakery. It's not a bakery anymore. A proud sponsor of Griswold High School Sports.
This is Ray Churchill from the Eastern Connecticut Performing Arts Association, inviting you to join us on June 3rd for the Eastern Connecticut Jazz, Soul, and Blues Festival at Urechko's Tree Farm. Our bands include Static, the Tim Fiervante Jazz Orchestra, the Mighty Soul Drivers, and the Effin' Blues Band. Tickets are available at ecpaa.org. Thank you to our title sponsor, MoheganSunCasino.com, as well as Jewett City Savings Bank, Collins and Jewell, DC Builders, Camaro Signs, and Nathan Kaliva Realtor. The Eastern Connecticut Jazz Festival, June 3rd. Get in the swing.
Your community radio.
Live from Main Street.
Mike Minarski and Rich Wasilick in the morning. And 80s all day and night.
SNSN.
What's up, everybody? All right, we have a very special show today. One we had kind of going away from the normal, boring town crap that we do.
Yeah, thanks.
We're not going to talk about, any kind of Griswold or Jewett City stuff today, which isn't really boring, but this is just something a little bit different that we have never done before, and we've never done the topic of space and the final frontier.
Space. I need an echo and maybe some reverb.
Can you skip rocks in space?
You would need gravity.
Actually, some space rocks have skipped across the Earth, which is frightening.
That's kind of cool. How does that happen?
Move that a little closer to you.
I will. You have a little VU meter? Check.
There you go. Yeah.
Hello. Okay. Yeah. Oh, anyway, I'm John Filhaber.
Hey, John.
How are you doing?
I haven't even introduced you yet.
Well, I could introduce Michael. Michael and I went to high school together, and we were in Boy Scouts together.
Yeah.
And I graduated Griswold High School in 1981. And then I went to Wesleyan University, studied astrophysics. And then after 6 years, I graduated. My freshman year was the best 3 years of my life. and then I went to Chile, worked on a little telescope in Chile, and then I worked
how long were you there? 10 years?
First year, I was down there for 1 year, isolated on top of a mountain in the middle of the Andes in the southern Atacama Desert. And
see, this is stuff you only dream of hearing in stories.
Like you don't hear that real people do this stuff. Okay.
It was the coolest thing in the world. My house was on the summit of the mountain. I mean, other astronomers would come up and down. They'd visit the telescopes, but they get to go down after like 5 or 7 days.
Right.
I'd be up there for a month at a time.
Wow.
But it was incredible. My house, I had the best view in the world. I could see 100 miles in any direction. The Andes behind me were like, to the west were 20,000 feet high. We had a snowstorm once that dropped 6 feet in a day. Wow. And stranded us on the mountain for a while, for a week at least. And the main communication back home was shortwave radio. And so we would communicate twice a week on 20.5665 megahertz. And my call sign was Victor Echo Niner Lima Hotel Mike. Or anyway, I had
That's a mouthful.
Yeah. But anyway, so a little telescope there. And then I worked on bigger and bigger telescopes all over the world, Chile, Hawaii. And then I joined the for-profit world after completing a giant telescope in Hawaii. And
I never knew about Hawaii, to be honest with you.
Oh yeah, Jay went out there.
I know he went to Chile, but I didn't know he.
Wait, no, maybe he didn't. Sven went out to. No, Chris, another mutual friend of ours, Chris LaChapelle from over there, Sven Johnson's daughter. She's in Paultown. Sven's in Hopeville, right? Yeah. And I worked for Sven for a few years going through high school. Extraordinary influence on my life. But anyway, so I've been all over the world, Hawaii, and the last big telescope I built was not by myself, of course, but with about 220 million of your tax dollars and a few other friends. No problem.
Thank you for your service.
Thank you. It's peanuts, it's less than a B-1 bomber. So we built 2 telescopes for that, 2 of the biggest telescopes the United States owns on the ground. So
and they're in Hawaii?
One in Hawaii and one in Chile.
Wow.
Gemini telescopes, Gemini twins, 2 telescopes.
Got it.
Cool machines. But anyway,
so I always have a million questions. They probably seem so sophomoric to you, but I mean,
that's good because I'm sophomoric. My humor is definitely sophomoric.
Oh yeah, I know. But I think a lot of the questions I have no idea what goes on up there. So like, here's one of the questions I've asked John in the past. And have you ever seen UFOs?
Excellent. As a matter of fact, I have. And because I read about UFOs, and as a little kid, you hear about UFOs. They had all these cool stories and shows on TV, and man, I wanted to believe in UFOs so bad, and spacemen, who doesn't?
Aliens.
Dinosaurs,
And
spacemen, stars blowing up laser beams. And so there was, when I lived in Chile the second time, I was down there for 3 years. And I'm on the summit of Cerro Tololo, another national observatory the United States owns, and I think one of my best experiences ever. And observing at a telescope is kind of a cool thing. Astronomers don't look through telescopes anymore, and they haven't since mid 1800s, maybe. As soon as photographic plates or photographic film was invented, originally it was on glass plates. You don't look through a telescope anymore. And there's an instrument on the back. But so when you get to the mountain, in the middle of the day, you prepare your observations, you get the telescope ready, you get the, cryogenics, because typically your instrument might be cooled down in liquid hydrogen or liquid helium, and it takes a while to do that.
Absolutely, yeah, sure. I know all about that.
Yeah. You calibrate the thing.
I do that with my telescope at home too.
Yes.
Yeah, you calibrate the instrument.
The microscope, completely different. We got to heat that shit up.
Yeah, that's right. Yeah. Why not? I think you should. And I keep mine toasty. And so once the telescope's all ready, then you go to dinner and the other astronomers are there. And, astronomers from all over the world will show up. And you do it after dinner. At dinner, you're talking about, the latest discoveries in astronomy or, just politics or whatever. Then you go outside and you stare at the sky, as the sun is setting, because you really can't work until the sky is really dark. So by the time the sun hits the horizon, then you're off to the dome. And it doesn't matter, if it's early in the day in the winter or it's late in the day in the summer, you're off to the dome. So we're staring off Cerro Tololo, looking out over the Pacific Ocean. We're about 40 miles from the coast, about 7,000 feet up in the air, 7,500 feet. And I look to the north and I see this glowing gold ring, in the sky. And if you held your hand out At arm's length, it's about maybe 2 inches in diameter in the sky. That's how far you'd put your fingers apart to estimate it. So it's like 5 degrees or something like that in the sky, and that's pretty
I was
weird.
going to say that sounds pretty big.
Yeah.
How far actually
the sun's
was
a
that
half
away?
a degree in diameter.
Oh, okay.
Sun's a half a degree. Sun and the moon about the same size.
Okay.
The sun seems big. Moon seems big, but they're really only a half a degree. You can cover it with your pinky nail.
Yeah.
It's like, whoa, is that small? Yeah, go out and don't stare at the sun. But anyway, so you see his ring, and Oscar Saw, who's was the head of the night operations at the time, who was 30 years on the summit staring at the sky. Arlo Landau, one of the greatest observational astronomers, was a guest astronomer there, who ever lived. And he was one of the people that spent the first year overwintering at the South Pole, 1957. He was there. And this is about 1995, I think, 6, something like that. Anyway, we're all looking at his gold ring. Every one of us, seasoned observer, I've got, years on the sky at that point. Now these guys have 10 times more than me. We're like, what the hell is that? Ever seen anything like that? No. And but we're thinking maybe it's a barium cloud experiment or something like that, where a rocket would launch, and rockets are launching into space all the time. And sometimes the first stage of a rocket will sell space on the first stage, all right? And it'll dump off little experiments on their way into space. And a barium cloud experiment is when they release gas, like barium gas. And there are a couple of different gases, strontium, they'll release, strontium's a metal, but anyway, they'll release things and they'll glow, they'll bounce radio waves off, and you can learn about the other upper atmosphere. And so he said, well, that's probably what it is, because if you think about a bubble, you blow a bubble, it looks like its edge looks like a ring from any direction. Why would this look like a ring to me, especially because it could be an oval if it were a hoop, So we figured, okay, it's probably a shell,
But was it a spaceship?
Well, people think it was, and so I called my wife Amanda, and she was down below in La Serena, about 25, 30 miles away at the coast, and I said, honey, go outside, take a look up. You see, a spacecraft up there? No, but I see a glowing ring in the sky. It looks circular, and it's, about the size of my fist or something like that, and it's just slowly drifting to the north, Like, okay, cool, thanks, bye, click. And that was it. We stared at it, and then we went about our business, and it kind of slowly expanded and disappeared. The interesting thing is not so much what it really was, but how it was reported the next day in the news. Next day in the news, it was spinning, making impossible right angle turns. It was flashing. Cows were tipped over. Dogs were laying down in the manger. It was all kinds of craziness. And it's like, okay. And so it turns out it was a barium cloud experiment. None of us had ever seen one before. It's really pretty cool.
That is cool. So now, are you notified, or is there a way for you to know of those experiments happening or rockets being launched that would cause things like that?
That was just at the raggedy edge of the beginning of the internet.
Okay.
And
you said mid-90s or so, right?
Yeah.
So, yeah.
And we were just beginning to shoot lasers into the upper atmosphere with our telescopes. And there's a connection to that. If you're going to shoot a high power laser, we were shooting them into the upper atmosphere to make a fake star so that we could image that fake star. And it was be very bright. And we would adjust the optics of the telescope so that the real stars we're looking at, a bazillion miles away, become sharper. And so as soon as you start, we said, we're going to launch some big laser beams up into space. Then we had to talk to a wonderful group called Space Command. This is before our new Space Force.
Yeah, SpaceX or whatever.
We had Space Command?
Yeah, we had Space Command.
Oh, all right.
And it was great, because I'm always been a kid, and you had to call them up and say, we're going to shoot a laser, blah, 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 and here's where we're going to shoot it. But anyway, they'd answer the phone. Space Command. Awesome. And I would just,
really?
So
yeah,
cool.
I'd call him up and hang up. Call him back. Space
Captain Marvel
Command.
speaking. Can I help you?
Oh, I love that stuff, But they would tell us areas not to shoot lasers at,
Okay.
because there might be something up in space looking down, and they didn't want us to blow a hole in it. And we wouldn't blow a hole in it, but we weren't launching that much energy. But you just want to be safe, with our spy satellites and
Right.
stuff. So anyway, so they would tell us where satellites are, and you can look up the launch schedule from like Vandenberg. A friend of mine just sent me, Lisa Coe.
We know her.
Lisa Coe
The
sent
sister.
me.
Oh, that's your sister?
Yeah, that's my sister.
Oh, okay.
Yeah. Lisa Coe sent me an image that she took from somewhere in Lisbon of a really cool event. It looked like a comet. And she said, "Oh my God, what is it?" And she saw with her own little eyeballs. And she sent me a picture. And I said, "That looks like a spacecraft venting, and which looks nothing like me when I vent."
Or smells nothing like it either.
There you go. Anyway, I was thinking more ranting, but
He always takes it in that
I
way.
took it to another level.
Yeah.
Sorry.
anyway. So there's so you can look up. So I said, it looks like spacecraft venting, but you can look up the launch list out of Wallops Island, which is Goddard Space Flight Center off Maryland, Cape Canaveral, Cape Kennedy, that launch station, Vandenberg out in California, and Lompoc, just between, right around Santa Barbara. They launch a lot of stuff. SpaceX launches a lot of stuff. Now we've opened up launches down at Brownsville, Texas. Where else are we launching? Anyway, so you can look up and you can find all these launches, and a friend of mine just sent me something the other day, that he thought was pretty mysterious and exciting. And it's really cool. The stuff we get to see, you get to see spaceships landing side by side. When I saw that 4 years ago, that's when I said, I'm buying a Tesla right now. That's really it, And so they tell you all about that stuff. They're scheduled and stuff like that.
That's cool.
Oh, but you know what? With my wicked ADD, I will answer questions usually about 12 minutes later to half an hour. And we were talking about skipping stones.
Oh, yeah, that's right.
And then we got to Chile and Argentina. Anyway, a bazillion years ago, I don't know, 400 million years ago or longer, a little asteroid, maybe something like a few hundred meters in diameter, maybe more, skipped across the surface of the Earth in Argentina and then went back out into space.
Really?
Yeah.
Like it hit the ground?
Yep.
How does that happen?
Made a
And what kind of
grazing
damage?
angle. It just, well, you can see the pockmarks today. So
Really? How long ago did that happen?
hundreds of millions of years.
Oh, okay,
I just
okay.
heard about it, and so I didn't really fix the time in my head.
Okay.
So
And you can still see where it happened?
yeah, up around, I think there's a place up north of Montreal that they actually use as a reservoir for electrical power. You can see this perfect ring, a big, huge ring in the ground. I don't know if it's, 20 miles in diameter or something like that. That's a leftover that's a very close impact.
Wow.
huge
That's
impact.
Montreal, you said?
Yeah, I think it's north of Montreal somewhere. You can look for large asteroid impacts.
Huh.
You look at asteroid impacts all over the globe. There are some huge ones. There's one off the Yucatan Peninsula that potentially killed all the dinosaurs.
In the ocean?
Yep. Yeah, it was dark few million years.
So are there space people or not?
Negative. Are the space people? 100% yes, without a doubt. Why do I believe that? Ever since we were kids, astronomers knew that there were other planets outside of our solar system. But that was a huge revolution in science and in astronomy in particular, is that even when I was in college, we only knew of, the 8.5 planets. Pluto can be a planet today if it wants to be. I'm okay with that, And but we only knew of those. We didn't know of any extraterrestrial planets at all. And then massive discoveries of planets. I mean, these are real, true, verified discoveries of planets, all very close to the Earth. Okay. But if you think if you keep this in mind, there are about 200 billion stars in our galaxy.
Yeah.
200 billion galaxies.
It's got to be,
Yeah,
you got to be pretty narrow-minded to think that there's
no
nothing
life anywhere
out
else.
there.
Yeah.
Yeah, there's this equation whose name I forgot, but you can look it up. Look up equation for how likely life is on other planets or in the universe. And it's, the fractional number of planets times the number of stars times the number of habitable planets, blah, blah, blah. And you get a number. What we really didn't know was how many planets there are out there. We just assumed they were out there. It turns out it's more unusual for a star not to have a planet than to have a planet. Because we've detected about maybe between 3,000 and 5,000 planets so far. And there was a really phenomenal satellite experiment that found most of those. Okay. And it outlived it. It's done now. It lived its lifetime and it's done. So there'll be more, and there's more searches from the ground. But why only 1,500? Where are these rest of these 200 billion? Well, the thing is, we only have the ability right now, because stars are very far away and planets are really tiny, and they reflect a tiny bit of light, or block only a tiny bit of light from the star when it goes in front of it. And the geometry of the orbit sometimes doesn't allow the planet, or most of the time won't even allow the planet to go between us and its star. So if it were there, we can't detect it. But statistically, we understand our sample. We understand our limitation. We can only look out to, let's say, a few hundred light years. Okay.
That's it?
Well, no, we can see stars all the way to 13.7 billion light years.
Wow.
We can only detect planets out so far to, 100 or 200 light years, because it's such a ridiculously tiny amount of light. I was on projects where we got this 8-meter diameter telescope. Here's a telescope as big as a big above ground pool, okay, in diameter, collecting all this light for 2 hours, at a time. And you get, 8 photons. And that would be, whoa, I got 8 photons from this distant quasar. I can see the damn thing. And planets, the same thing. They're teeny tiny things, And so anyway, we can, every place we can detect one, we have the ability to detect one, we find one, okay? And our part of the galaxy is not special. We're about 2/3 away from the middle. We're about 27,000 light years from the center, from the supergiant black hole in the middle of our galaxy. There is one there, and it will not eat you. But it's there, and it's pretty cool.
Is it a wormhole?
Will we time travel in it? Will we go to a different dimension, John?
If it's spinning. By the way, what was that movie, Interstellar? The physics in Interstellar was extremely accurate. Okay?
Really?
Yeah. Yeah, they had one of the greatest physicists of all time, Kip Thorne, as a as a consultant for that. And actually, almost a writer effectively. And anyway,
there's a comment here, and I just want to tell you what it says and see what you got to say about it.
Well, let's go for it.
Oh, I hope it's a conspiracy theory.
No, well, yeah, it could be.
Okay.
His name is Mike. I can't really pronounce his last name. Is it Greka or Greka?
Ramish Minarski.
Yeah. And he just typed in 3 words. Space is fake.
Okay.
Space is fake.
Space is fake.
There's some really, really cool physics and cosmology that
not cosmetology.
It's not that much different, really. Cosmology. It's like astronomy and astrology. Yeah. It's like somebody said to me once, I was in a bar, it's like, oh, you're an astronomer. And it's like, and I said, yeah. And he said, well, can you guess my sign? I was like, you're a feces. No, I think I'm a Sagittarius. Okay, good. Anyway, all right.
Real
Fake is
quick, before
fake.
you answer that, what are your qualifications? I don't think we talked about that yet.
I've been dropped out of some of the finest schools in the universe.
Perfect.
So, Columbia University. I was a graduate student at Columbia University, and I dropped out of Columbia University to go to Chile to work at the time, the United States, well, it still is the United States' biggest observatory in South America. And actually, I think it's still the U.S.'s biggest observatory in the world, even though Gemini's anyway, whatever. So that's it. So I worked closely with astronomers. I was going to be an astronomer, but I fell in love with building instruments and then building telescopes and doing engineering. And I figured that as an engineer, I would get an awful lot more telescope time than I would as an astronomer.
Mm-hmm.
And but I could also do what I loved, which is engineering, building giant things. And as a little boy, I wanted to build. I used to read about Palomar. And I was born in the early '60s, and I was born as a very young child. And
I was born a very old man.
that's it. And so Palomar was already working when I was born for actually not that long. Now I think about it, only 10 years. And because it really turned on in '54 after the war. And but anyway.
But is there space?
Oh yeah,
there's fake
space because you can see satellites going overhead.
Yeah,
you can see. You go.
Maybe it's just a big movie projector screen.
Is it like the Truman Show where everything is just, yeah.
I have worked on rocket projects and satellite projects that have launched. Okay. It used to be back in the day, if you took an international call, it almost always went through a satellite. And so there would be a little bit of a delay because satellites are about 20 geostationary satellites, the communications ones, the ones that stay, they're orbiting at the same rate as the Earth is turning.
Mike says firmament.
Firmament.
That's what the dome, that's the name of the dome. That's what I was talking about. Yeah, I knew there was a word for it and I couldn't remember.
Yeah.
Okay. Yep.
And,
whoa. Now we're getting religious.
Oh, geez.
Psalm 19:1.
What is that?
It's part of the Bible, I'm assuming.
No, I know, but I don't know what it says.
Yeah, I want to.
Chapter 19, verse 1.
Yeah, I should have made this as an as a prologue. Okay, is that when you're taught science, okay, you're not taught to believe a theory or to believe this theory or believe that theory. You're taught how to do science. And there are 3 extremely important lessons I got in science. And one of the most important lessons, really profound, that I ever got in science was from my math teacher at Griswold High School. And
would that be Mr. Leeper?
My math teacher.
Lemire.
No.
Gerbert.
Gerbs.
Oh my God, my favorite teacher of all time.
He was truly brilliant.
Yeah, he was.
And here was the lesson.
He was so misunderstood, that man.
Oh, he was fantastic.
Yeah.
He used to bust my chops, but I mean, I loved him. And the most important lesson I got from him was, at the end of advanced math, which sadly in that school at the time didn't even have calculus, but Gerbs gave me a little bit of calculus, and I love the guy for it, Mr. Gerbert. And it was a guy with the best posture on the planet, by the way.
And made the most incredible
circles.
You
You could draw a circle. It was beautiful. At the end of the year, he just started with, okay, here's what you know. 1 + 1 = 2. All right. And he took us from 1 + 1 = 2 just through logical deduction to algebra, trigonometry, exponential, and then to calculus. Boom, in 1 hour. And what you learn is method and deduction. Okay, so that was lesson number 1, extremely important. Lesson number 2 was really cool. Another physics teacher from my previous high school in New York had a slinky on a table, and he wiggled the slinky, stretched it out along the table. And he said, "Kids, what did you see?" And his name was Hugh Clearwater. He was Air Force vet, wonderful guy, also impeccable posture and grooming skills. These are very important. And I have none of which. and so he'd make this little wave, go travel down the slinky and say, "What'd you see?" And everybody'd say, "Oh, I see a wave moving on the slinky." He'd say, "I know what a wave is." "Well, what do you see?" And we just stopped and trying to describe what you see. And finally, you got to, okay, we see parts of the slinky getting closer together, and then it's getting further apart. And as time progresses, that area is moving along. And he said, "Okay, that's better."
Mm-hmm.
So describe in the clearest, most fundamental terms what you see. So that's what we were doing on the mountain that night, 30 years ago. We all looked at it. What do you
that light ring?
actually see? That light ring is our light ring. And Amanda actually, saw the same thing. And in a way, she's a trained observer too, maybe better than me. And she's an artist, and she paints what she sees, And that was lesson number 2. Lesson number 3 was the most boring class I had at Wesleyan, taught by this old guy, Arthur Upgren. There's an asteroid named after him. And it was about galactic mechanics or something like that. And it was really about the motions of stars in our galaxy, which was kind of boring. But it was really, really about making very difficult measurements and knowing the errors. And he started out with every measurement you make. Now people will run with this and just take a soundbite out of this and say, "See, it's a lie." He said, every measurement you make is a lie. Your job is to find out how consistent is the lie and how big is the lie. And what he means by that is, let's say you take your temperature with a thermometer. Okay. You're trying to find out your body temperature. Is it really your body temperature? No. It's how far the mercury in the little glass tube moved. Is it really measuring your temperature? Well, it's measuring the expansion of the mercury, which we know pretty well, extremely well, as a matter of fact.
See, I'll never look at a thermometer the same.
But is it really measuring your temperature?
Right.
Your body temperature? Well, if you just ate, had a cold glass of iced tea, there's a measurement error. And it's like, how many ways can this measurement screw you up? Okay. And that's where you start in any science, biology, even surveying. You're going to put down a road, how well do I know where this road is? I'm going to make it from this marker over here. Okay. Surveyors, are phenomenal in controlling those errors. And that's all they talk about are errors in measurement. Everything has an error.
And that's usually where statistics come into play.
Very
and
much.
The standard deviations and
Yeah. Nicely done.
I hated statistics.
All right, here's a question from Cortland. How long will it be before a human can travel outside our galaxy?
Ooh.
See, this is the kind of stuff we want to know.
Stuff.
All right. Well, let's go there.
Because I have another question too, but go ahead.
Okay. Right now, the farthest a person has ever been away from the Earth is 250,000 miles. Okay. And the last people to do that were Apollo 17. Okay. 6 people have walked on the moon. 6 different people. Okay.
But did they really? Because I heard it was really just in a set in Hollywood that
the
they
moon
did
isn't
that.
actually real. Buzz Aldrin, who I met Buzz Aldrin punched a guy out for saying that. And he was like 80 when he punched a guy out.
He was a tough dude.
Oh, Buzz is awesome.
Yeah.
Buzz is really my superhero. So we're going back to the moon probably in a few years. We're going to Mars probably a few years after that. And we're probably not going to get past Jupiter for thousands of years. You know, because the next nearest star to us is 4 light years away. Okay. Light year. So that's light year.
What is a light year?
Light year is how far light will travel in a year. Okay.
Okay.
And to give you an example, we sent 2 space probes, well, actually 4 space probes, now 5, headed out of our solar system 4 in the early 70s. And the Pioneer 1 and 2, and there's a really cool science problem about Pioneer 1 and 2. Look up Pioneer anomaly, kiddos. That is cool unsolved science trickery. Okay? And as scientists aren't being sneaky, they're just like, what the hell's going on with this little anomalous measure? Anyway, it was really cool. But Voyager 1, Voyager 2, remember V'ger. What was that movie? Search for Spock's brain or something. I don't know. But anyway, Voyager 1.
Star Trek 3, The Search for Spock.
Yeah, maybe. I think that might be it. Voyager 1 is 23 light hours away, and it's traveling away from us.
It's still going.
Oh, yeah, and it's going to go forever because it is actually has enough kinetic energy to leave this gravitational well. Okay, you know, because you can think of it like a dent in the ground. All right, you get a beach ball and it's sitting in a dent in the ground. It has to have some energy to roll out of that dent.
Mm-hmm.
You know, and provided by wind, or maybe it's got a leak in the side, it'll blow it out. You know, but there's potential energy to get out. We've only made 5 things now with enough potential energy to leave. Yeah, we could send one every day if we wanted. We just haven't tried, you know. But it is 24 light hours away, maybe even a little bit more than that. Okay, but right around a light day. What I mean by that is at Goldstone Deep Space Network. I love that Deep Space Network. Really cool. These giant radio telescopes are they're radio antennas, radio dishes. You know, 300 feet across, pointed at it, you know, as it's heading out into the, it's actually out of the solar system now, okay, are pointed at it. They send a message, hello, spacecraft, how are you doing? And then they don't go get coffee and wait for the answer. You know, they go on a little mini staycation at home for the weekend. It receives the message the next day. It's traveling at the speed of light, okay? It used to, you know, here's another thing I didn't finish. When you used to talk on the phone, your signal would go up to the satellite 25,000 miles away, then come back down. That's 50,000 miles. That takes about a quarter of a second. Okay. Speed of light is 186,000 miles per second. Okay?
Oh my God. Okay.
And so it goes up and back. You know, the sun is 93 billion miles.
Or 671 million miles per hour.
Yeah. It's Zoom. Yeah.
I'm looking at that.
That's cool. I mean, Google's the most wonderful thing in the world. And so is ChatGPT. It's even better, you know. And chat roulette's a different deal, so stay away from that. Yeah, don't ask it for asteroids.
So in other words, to get out of the galaxy, we're talking hundreds of years.
Yeah, I mean,
before because human can't really. I mean, we can't travel at the speed of light.
If we freeze dry you,
so we can send Walt Disney.
We could do that,
yeah,
you know. But that spacecraft has been traveling since you and I were like 10, approximately. So it's been traveling for 50 years, and it has only gotten one light day away. Okay.
Wow.
And that's it. We can barely hear it now. It's out there.
Past Pluto?
Oh, way past Pluto. Way past. It's 4 times past Pluto.
I think I'm more amazed that technology was available back in the 70s, or you know, like holy crap! Like the fact that we could do that long ago.
They work in that field.
Yeah.
Wow.
Okay, here's another one. Ready? Is the Earth flat?
Oh, yeah, it is.
It's a hexagon.
Super flat. Yeah. So because it's flat, no, I can't even do anything with that. I can't do anything with that. Just this weekend, you know, I was out in California and I was watching a container ship sail, you know, away in perfect seas, and, you know, watching it with binoculars, and you'd see it disappear over the horizon. The last thing you see is the top of the container ship. You know, you couldn't see the bottom because it's hidden by the curvature of the Earth, you know? Yeah. So not even a tiny bit flat. I mean, it's pointless to even consider it being flat.
But so it's not a complete circle either, though. It's more of a.
It is so round. It's a little bit oblate,
right,
but only
okay. Yep.
The Earth is about 4,000 or 8,000 miles in diameter, and so it's, let's say, I can't remember how out of round it is, but it's miles out of round, but not visibly.
Right,
so if you shrunk it down to
it would still look like a circle.
A little disc. This is something interesting. You take the Earth 8 inches in diameter, okay? Because I can do that math in my head. 8 inches in diameter, 8,000 miles in. It's really 8,000 miles in diameter. All the air that we live in is only, you know, most of us live below 10,000 feet. Okay, 2 miles of air. So let's say 20,000. There's some mines in Bolivia that are up at 20,000 feet. So let's say 4 miles thick. That's 1,000th, okay, of the radius of the Earth. Okay, it's 1,000th of an inch. So if you took a sheet of paper, wrapped it around approximately a basketball, something like that, that's the air that we live in. So
Yeah.
just think about that.
Mhm.
I'm not going to say any more about that, but it is so round there. I mean, there's satellites going around the Earth, and I've got a little satellite tracker. You can download them, okay, and you can call a friend in Australia and say, okay, the International Space Station is going overhead here, and it's also, I see it's going to cross you, and by the way, go flush your toilet and see if it swirls the other way. So that was the most common question I got from my frat members when I moved to Chile. They would call me up on the mountain whenever the phone worked, which was rare. Say, John, Quark was my frat name, and I had the best frat name. And they said, go flush the toilet and tell me which way it spins. So anyway, but you can see a satellite will go over here. I mean, the guys are up in the ISS, guys and women are up in this ISS, International Space Station.
And they can see
Looking
it.
down. They're in orbit and they're going around, and it's round, period.
Yeah.
Done. If you believe it today and you're an adult, I'm not going to change your mind.
Yeah,
So
no.
just keep on believing, and people, I was talking to somebody the other day and they said, well, gravity is only a theory. Yeah. It's like 1/2 GM M over R squared, blah, blah, blah. In the non-relativistic case. And I said, yeah, but it's only a theory, and I'd like you to test that theory. There's a parking garage over there. I believe it's 5 decks high. Go to the top of it.
Yeah.
Test that theory.
Yeah.
Baby.
Which way do you go when
Because
you jump off? Up or down?
It's precisely that theory. It was Newton that said, all right, because of this, I'll bet if I had a cannon and I shot it fast enough, parallel to the surface of the Earth, it would go around and hit me in the back of the head. It was Newton that figured that out. And by the way, the Greeks knew the Earth was round. The Greeks actually measured it in the coolest experiment ever. I can't remember who did it. Was Aristarchus or somebody can look it up. But the experiment was like this. This mathematician heard of a place in, where was it? In Egypt, where the sun would be straight overhead and shine straight down a well at a certain time of the day on a certain day of the year. Yeah. He said, oh, fantastic. That's great. All I have to know is what that day is. And he paid somebody to walk and estimate the distance between where the hell he was in Greece or wherever the heck it was back to this place, and he was a really good estimator. And he said, okay, if I measure the angle to the sun from where I am, it should be different if the Earth is not flat, And yeah, he actually got a fairly good, and his assumption also was the sun was really, 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 really far away. Okay. Now, somebody will say, well, the sun is really, really close and the Earth is flat, and that is just so ridiculous because we have things in orbit around the sun. We actually have a probe that's going.
It's just so ridiculous.
It's just ridiculous.
It's hard to even talk about it to people, because what I started with is when you learn science, you don't learn the theory, you learn science, and science is just, you start from basics, GMM over R squared. How do we know that? I'm just rattling off the universal law of gravity. Okay. How do I know that? How do I know relativity? There are phenomenal experiments. Scientists aren't set out to prove they're right. Your first goal, when you have a great discovery, and I've had a couple of really cool discoveries in physics and in engineering. Your first thing you're doing when you have a discovery like this is you're trying to prove you're wrong.
Yeah.
Because if somebody else finds it, it's unbelievably embarrassing. Yep. So you try to prove you're wrong, and so when you go to school, you just learn the basics, and how do we put it? Is there a logical chain here? Not, okay, I'm going to knock down this piece and that piece. And, I got some cruddy piece of data, non-statistical, you hear, I You say copper bracelets don't cure arthritis. Well, I have a copper bracelet and my arthritis is all better. I don't doubt your arthritis is all better, you know, and I don't doubt that it probably got better when you put that copper bracelet on. What I do doubt is the causality. Does this cause that, you know? And, you know, unlike a lot of people, I know a lot of scientists are very spiritual, and it doesn't drive their physics at all,
Right.
you know? And, you know, they believe in God.
There's nothing about that that's scientific.
Yeah, and but they believe.
Start
in
looking at the
God,
Shroud
and,
of Turin,
you know.
or whatever.
Oh yeah, that has been debunked 18 trillion times, you know. But it is a real thing, you know, and it's really pretty cool to look at, you know. And if in fact Jesus did walk around on the face of the earth, which he could have, he did have a phenomenal message. I mean, what a staggeringly important message that affected so many people in a good way, you know. And yes, I don't doubt that, but you know, there's causality. You know, if you believe, this is how fundamental believing the earth is flat is. If you believe the earth is flat, then you have to give up on the physics that makes these tiny little junctions inside the transistors, and there are millions of them inside your cell phone, because the physics inside just a transistor is absurd. You know, you think about what's going on inside of a star, you know, hydrogen is being fused together at, you know, millions of degrees under, you know, billions of pounds per square inch pressure at the shell in the center of the sun. And it creates, you know, a quanta of energy, a photon, you know, which is bangs into another electron, gets absorbed, and that little pile of energy, even though it's getting absorbed and re-emitted, takes like 10,000 years to get out of the sun. Okay.
Wow.
That's bizarre. You know, how could that be? You know, and sunspots, the things we're going to talk about today, which maybe we'll get to. What time is I could talk forever.
And that's not a theory, that's proof.
There you go.
I just want to get to a couple of layman type questions.
Okay.
And these are theories, you know, and this isn't
conspiracy.
Kinda, but this is not stuff you and I are going to be sitting smoking a cigar on the back patio. But is there an opening at the top of the poles?
Oh,
it's 14 miles wide.
Oh, that was.
Oh, I've never heard that.
My grandmother got me that book.
That's where Santa Claus lives, right?
No.
Oh.
No, it's supposedly it's the entrance to inner Earth.
Yeah.
At both poles?
At both poles.
No kidding. I
There
hadn't
was
heard
a
that one.
Cool book about that called The Hollow Earth.
Yeah.
Really cool.
Well, there's
book.
a hollow Earth theory. So
yeah. And yeah, you have to ignore some unbelievably fundamental and basic things. You have to ignore the fact. I had a friend who just passed away. I graduated from school with him. He spent 20 years at the South Pole. Okay.
Oof.
You know, not in a row, but he would winter.
Sounds
He
lonely.
wintered over 20 years.
High school?
Not high school, college. Excuse me.
Okay, all right.
John Booth and Johann Booth.
Wilkes.
And
Oh my God. That was my first thought too. I'm like, ooh.
he went back to the lowest end of the earth. There you go.
They
There
did.
you go. I smell a conspiracy. Anyway, no, there's not a hole there because we've been there and all the water would fall in, you know, and that would make us sad, you know. And so there's not a hole there because we've been there.
But is it
And-
just covered with ice glaciers?
Yeah, but then
Maybe
it
you
would
don't see
still
it.
fall in, you know. But we'd also know we can map the density of the earth.
That's where the reptilians are.
You know, as little satellites are going around the earth, even communication satellites, GPS satellites, they put little laser reflectors on them because it costs them almost nothing to do it. And you can do really cool geodesy, GEODYSEY or something, which is really the true shape of the earth, which is what you were talking about, because you pointed out quite correctly that the earth is not really round. Okay. And it's not.
Ego just went,
It was already like that.
No,
please.
I knew you were
fine.
smart. I texted you when you were talking. When is it? Monday or
photons
Tuesday?
are fun.
No,
Yeah.
after photons are fun, and
Yeah.
after I disparaged your whatever,
Michael
I did
Bublé.
say, what did I write? I wrote, She's smart.
Oh yeah.
Oh no, she right. That's
She right.
Yeah, but anyway.
All right, so there's no opening up there.
No, because I was going to say we have these satellites running around and we range to them with lasers extremely accurately, and it's important for us to know the true shape of the Earth, how not round it is, because the little GPS satellites are perturbed by that and they wiggle and move, and so that helps us know just by their orbit from the universal law of gravity what the mass distribution and the shape of the Earth is. So if there were a hole up there, we would know.
Okay.
I mean, it would be the biggest, coolest thing in the world.
Sure.
I mean, think of the extremely embarrassing things that happen.
I want to go see Mr. Frodo.
Oh my God.
I want second breakfast.
Yeah, I mean, people talk about chemtrails and
Oh, yeah.
all those other things.
Yeah.
If there were, just think about how you could possibly keep that secret. Presidents can't keep anything secret. You know, Bill Clinton found that out. You know, it's like, and so if they couldn't keep that secret,
What are you talking about?
but there may be presidents that don't even remember what day it is, so they could keep secrets and not even realize they're keeping
True
them.
True that.
I don't know.
But anyway, so there's no science conspiracy, because scientists love to discover and they love to disprove. And there is a democracy in science which does not exist.
So there's no opening up there. There's no 14-mile opening.
Not only that, you'd see it if you fly over. If you're flying,
here's something really cool.
If you're flying over it, I mean, you'd see a 14-mile wide hole. I mean, planes fly over them.
You're supposed to go down there, and there are people that are friendly down there.
Well, why aren't they coming out?
I don't know, because reptilians are holding
introducing themselves.
We're Cookie Puss. Tom Carvel, the ice cream cake, whole cold.
Yes.
But I'll tell you, I'll leave you with one. I'll leave
I
that question.
I got one more question for you.
But I'll leave that question with one interesting little factoid. I can answer questions all day long.
Fudgy the whale?
If you drew Fudgy the whale, yes, you look just like Cookie Puss, just different. If you drill the hole through the center of the Earth, okay, unlike
you get to China.
You get to China. Well, from
now
here,
we know.
Indian Ocean. So let's say you kept everything from falling in, but let's say you decided to jump in, okay? What would happen? And you'd have to do it from the North Pole to the South Pole, because if you did it like on the equator to the other side, the antipode, that's the opposite point on the globe, you would Coriolis effect, because we're spinning on a globe, we would smash into the side and you get rug burn all the way down. So you don't want that. No rug burn. So you do it from the North Pole down to the South Pole. Drop a bowling ball. We won't drop Mike down there. We'll drop a bowling ball down.
Same.
It would get to the other side in about 45 minutes.
But would it, because of gravity? You would end up stuck in the middle.
Right?
I was thinking about that.
You are
and
way
that's
wicked
that's
smart.
where Mr. Frodo is.
But what would happen is you'd accelerate, but your acceleration would get slower.
Mm-hmm.
But you get to the middle. And what happens in the middle? Say it. You're right.
You'd get stuck because the gravity would be going the other direction at that point from the other side.
There's zero gravity. There's as much Earth.
It's like that, equals each other, like cancels each other out.
So you would, if you're able to stop, okay, and lose that, because you'd be going pretty mighty fast by the time you got there. If you're able to stop, okay, you would just float around. Exactly right. You would float. Your intuition is stellar. Okay. You would float around.
I was going to say the same thing. She just said it first.
Yeah. Anyway, you'd float around. But since
don't ask her about rug burn, she's got a whole different theory about that.
Whatever.
Since you fell down the hole,
ask her about it this morning.
Oh yeah.
See that look?
She was caught in traffic.
I was.
Anyway.
Did you see that look? It was like
he's trying to explain something.
All right, whatever.
There you go. Mm-hmm. But anyway, but it's interesting. You get to the other side in about 45 minutes, because you're speeding up, but you're not accelerating anymore, but you're not slowing down when you hit to the center, because the whole Earth is pulling in every direction equally. And so it all cancels out. So you're not accelerating anymore, but you have your momentum, your kinetic energy from being 4,000 miles away from the center of the Earth, and now you fall. Anyway, so you're zooming through at a bazillion miles an hour. I can't remember how fast it is, but now you start slowing down as you get to the other side, And if I were on the North Pole, Mike's on the South Pole, Mike could reach out and grab that bowling ball because it would come to a stop 45 minutes later and he'd grab it. But if he didn't, it would go back and would show up in 90 minutes or 92 minutes or something like that, which is exactly the time it would take to orbit the Earth if you were at the surface. It's just cool.
Would you want to jump in that?
Hell no. No way. I wouldn't want to jump into a big
fun.
Dark hole. No, if it was lit up really well, then yeah. I mean, if it was lit up all the way and I could see what was happening, that would work. Yeah. If it was like a water slide, yeah, I could do that. If it's lit up.
If the Earth were a shell, a hollow shell.
But how fast would you be trapped?
You're right. You'd float around in there.
Yeah.
And it'd be fun, but it'd be hard to raise crops, Toilets would be very messy,
I wonder what direction they would spin in there. Right.
Good question.
Up and down.
Yeah. Don't even want to know. All right. One more question because it's almost 10 o'clock.
Oh my God.
Yeah. Is the moon really a space station that was built on Jupiter and moved around the Earth?
Oh, I hadn't heard that one.
In different planets and has a breathable atmosphere with a population of about 500 million.
Yes.
Okay.
Wait a minute. That was a lot to unpack there. Say that. Can you, what?
Why does everybody want to ask questions 2 minutes before we get off the air?
The moon.
Where were y'all?
The moon is on Jupiter.
No, the moon is really a space station constructed on Jupiter and moved around all over the place.
All over Jupiter?
And it's really a space station.
Okay.
But
where the Greys are, the reptilians, and the galactic universe.
There is some really cool stuff about Jupiter, though. Jupiter's moons are spectacular, and Jupiter's moons and Saturn's moons are the key to, I think, interstellar spaceflight. I really do think they are, because you need an energy source. But is Jupiter a space station?
No.
Is the moon? I will say, kind of. I'll give partial credit for that, okay? Because the moon it appears the moon was captured, okay? And early in the history of, 4 billion years ago, we've been around for about 5 billion years. So 4 billion years ago, early in the history, something like that, the moon collided with the Earth, okay? And chunks of what is now the moon, okay, collided with the Earth, left bits of the moon here, bits of the Earth wound up on the moon. But it was a big fractured mess. There's certainly no life here because it's such a catastrophic collision. Atmosphere can't even survive that, And so it wound up being in orbit and very close. The moon is slowly moving away in its orbit, Right now, the moon, gravity the tides of the moon, stretching the moon, have caused the moon to stop rotating relative to the Earth. That's why one face always faces Earth, okay? And but it's slowly moving away because the tide that the moon raises on the Earth makes the Earth a little oblong, and it's kind of like a little tether. The near part of the Earth leads the moon in orbit a little bit and pulls it. So the Earth's rotation is slowing down, and that energy is going into the moon, and the moon's going farther away. So it moves away like a centimeter a year or something like that.
So do you think that's the effect on weather and things like that? No. The moon definitely has an effect on weather, but it's pretty continuous. It's every month it does something. Yeah. And the sun has an effect, and space weather has an effect on weather, which we never even talked about today. But we can talk about that. We got to do that. We gotta talk about that the next time.
But space weather is really cool.
And
we didn't even get into that. That was kind of what.
There's so much to talk about.
Space
weather.
There really is. Aurora, space weather. Space weather matters. Look up spaceweather.com. And right now, sunspots. We're at a sunspot maximum right now. And the sunspots will be maximum for, there'll be a ton of sunspots for a few more years, maybe 2 years. And then
that's before it blows up.
Yeah, right before it blows up. And that will be Tuesday, January 12th, 2032. Okay. I just started a religion.
32, man.
I
There's
just
lots to be
started
said
a
about that.
religion. So anyway,
how much time do you have?
I got N minutes where N is pretty significant. I got to be in.
You do have to be in the office, though, you said.
Yeah, I have probably.
Kyle, I've gotten a lot of mic questions already.
I got 20 minutes.
Somebody said get a Mike Greca question in there. We've already done 2.
Mm-hmm.
So let's move on to Bobby. Talk about the twin paradox.
Oh, that's a cool one. Bobby's done some reading. Smart, wicked smart. The twin paradox is has to do with the resolution of the twin paradox is pretty tricky, but the basis of the twin paradox is that I'm sitting here on Earth and I have a clock. Okay. My twin brother, Michael, gets into a rocket ship and travels at some fraction of the speed of light. Okay. And he's carrying a clock too. And so he goes, let's say he goes out to Alpha Centauri, the nearest star, 3.8 light years away from us. And so he travels out there, has a good time, comes back 40 years later. Okay. But because he's been traveling in near the speed of light that whole time, we can pick a speed, okay, that you have only aged about, let's say you aged a year, okay, in that 40 years time, okay, and you got out there and then you came back, okay, fantastic. I'm 40 years old. I'm dead, okay, and because I'm now 100, okay, because I'm 60 approximately, so I'm quite dead. But the twin paradox says, well, from the standpoint of Michael, I'm the one, that was moving away at the speed of light, because everything is a frame of reference, when I was flying back in a jet and I was unbelievably stable air. It was like in my living room. You have 0 sense of motion, okay, relative to the earth below me is moving 520, miles an hour. I'm 38,000 feet in the air, okay? And, but now how do you resolve this paradox that, because to me, the earth is moving, at 500 miles an hour and I'm the one sitting still. That's fair, okay? And so the twin paradox says, well, why didn't Michael age? Doesn't the physics work the other way? It should.
Time is time, correct?
Classical mechanics falls apart in relativity, okay? And so the first part of relativity, special relativity, just talks about, let's say a steady state, what's happening. But here's what breaks the paradox. It's called an inertial reference frame, okay? And what I mean by that is what's the difference between me on the surface of the earth and you in an airplane, okay? You're moving 100 miles an hour away, but anyway. So it should be the same, but it's not quite the same because at one point we were both together and at one point you were accelerating. You felt the seat of your car push you in the back, or seat of the airplane push you in the back, just like I did. So there was a difference, and that's what breaks the twin paradox. In order for you to start accelerating up to the speed of light, okay, you're in a non-inertial reference frame. But all that means is that you are accelerating, and that's where the profound physics of relativity is really happening, okay? And this is a real screwy, this is going to be a really crazy answer, but try to look online. There's some really good stuff about this that can explain it better than I can. But that's how you start to break that paradox, because it's not the same. I was not accelerating. You accelerated. That's why you're the one whose clock gets to slow down relative to mine, okay? And that's why my clock speeds up relative to yours, okay? So as far as you're concerned, you're aging the same rate. You're looking at me with a telescope and I turn into a prune in a heartbeat, okay? It's like, son of a bitch. It's nice to know him. And so that's the difference, is the one party was doing accelerating at the time, okay? I loaned you a book, Space-Time Physics. It's in that book by Thorne and Wheeler. I think Kip Thorne was one of the guys. It was either that or Archibald Wheeler. Both of them have a Nobel Prize, because they're both pretty awesome dudes.
Yep.
But that was an excellent question.
I'd never even heard of it.
The twin paradox. Yeah, it's a really cool problem. And here's a crazy thing. Are you accelerating right now? How do you know?
Because we're on Earth, right?
Right. And
we
you're
just don't feel it.
You actually do.
Okay.
Step on a scale.
No.
Okay.
No.
Step on a scale.
No, thank you. I'll take your word for it.
When I said before the inertial reference frame, you are actually accelerating. And that's part of general relativity, the really tricky part of relativity, that in a gravitational well or gravitational potential, or you're standing on this thing, you're actually, how do you know you're accelerating? Physics, force equals mass times acceleration.
Mm-hmm.
And so in my car, when I'm going, my car doesn't use a lot of energy when it's going 50 miles an hour. It uses its energy to accelerate. I don't feel the power of my vehicle until I push the gas pedal, okay? And then I feel it pushing on me. So that's the force, okay, that I feel. And the amount of force I feel is my weight times the acceleration, okay, 1/2 AT, the acceleration. And so here on Earth, we're accelerating. And that means that on Earth, our clocks are actually a tiny bit slower than a clock in free fall or a clock in orbit. Okay. People say you're on orbit, the space station, there's no gravity. Oh, there's gravity. That's what keeps it going around in a circle. There's as much gravity up there, almost as much as it is down here.
Oh, really?
Yeah.
Huh.
Yeah.
Didn't know that. Okay.
Yeah. The gravity works, it's going everywhere. What's happened is it's no different than, let's say I drop you, out of the spaceship straight down, if you assume you're not on orbit. Okay. I drop you, you'd feel weightless. When the elevator cable breaks, you feel weightless. Okay. When you're up on, when you're on the space station, you're still falling, but you're moving so fast to the left that the amount you fall down, okay, is compensated by the amount you travel left.
Okay.
So it used to bug me when I was a kid reading science fiction because my own vision of science was easier than reality, and I'd be reading science fiction. They'd call it free fall. It's actually correct. You're in free fall when you're on orbit.
So this guy, Mike here, which I don't think I know, that's okay, is not buying anything you're selling.
It's okay.
Let's say that's okay. So what I would like to do is I would like to invite Mike and you to have a little chat off right here.
Right.
Everybody can put their money where their mouth is. So, Mike, what do you say? We'll see. We'll see what he says, and maybe we can have a conversation between us and see if you guys can disprove each other.
Yeah, there are people that can be convinced and people that can't be convinced.
No,
I'm not looking to convince anybody. I just want to have just a chat, just to have a conversation. Yeah. Mike, what do you say about that? I mean, I respect everything you got to say. Why don't you bring it on in here and we can all have a talk.
And he's not the only one. I mean, there are a lot of people out there that, that question a lot of these things and, and maybe for good reason or maybe just for some, not knowing.
So there's some comments in there that I did not get to, like from Facebook user who didn't click their name so we could see it. The moon is a Death Star. Sweet. Love that theory. LOL, laughing emoji. Let's see. Chris says the moon is made of cheese.
Wednesday day, I believe. And actually that's
Swiss,
close.
Right?
You want to, one of the best.
Mike, still waiting for your answer.
Mm-hmm.
Check out Wallace and Gromit. I think it was A Fine Day Out. One of the best space movies ever. And everybody should go watch it. It's wonderful. I love it. I could watch it a million times. Wallace and Gromit, they actually prove, and if you've got kids, definitely you got to see all of the Wallace and Gromit movies.
So Mike says, how do I chat? You come into the studio.
Oh,
and you sit right where Kathy is,
and
we'll set up a time where John is available and you're available, and we'll have a conversation. I think that would be fun. Serious.
I think that'd be pretty cool.
Awesome.
So, and Chris also said when we were talking about Inner Earth, does it exist or anything? Chris says, or he asked the question, is that where Bigfoot winters at?
All right.
His name's Daryl.
That's the other thing.
His name is Daryl.
You'd figure that's one thing about conspiracy theories. The proliferation.
Oh, Mike says, sorry, got 3 young kids, 0 time. Sorry.
Yeah.
Maybe dial in. Doesn't have to be here in person, right?
I don't know. He only has time to type.
Oh.
Yeah. And anyway.
Well, we should wrap it up. At this point, it's
I think we should do it again,
10.
though.
We
It's pretty
definitely
cool.
need to do it again.
Physics is fun.
Yeah. Now, the reason why I invited you in, Mike, is because you have a lot to say, and which is fine. And
it'd be a good conversation.
It'd be a good conversation. But if you can't make it, that's respectable too. But we would like to have you come in and talk about your theories that you have. So anyway, we'll do it again.
That was fun.
And then all the questions that we didn't get to or whatever, we'll get to them another time, if depending on who has time and who has not.
Mm-hmm.
So anyway, Kathy, thank you very much for coming on in today.
Sure.
Thank you.
And John, always.
Like, Kathy, are you going to run for public office in town or something? I love what you said the other day. Really, it was like Norwich too.
Mike, we'll go ahead and we'll have that question when you come in. How's that? Because I would rather have you ask that one in person.
Oh, must be a good one.
Yeah, now, they're all good ones, but we got to stuff before.
I like to.
That he commented, but we had to get other people in there
Mm-hmm.
too. So.
Yeah.
But I mean, we want to hear both sides of the theories, and this is not a claymation death match. Or
No.
Oh, but it is. Watch Wallace and Gromit. That's the only proof that the moon is cheese that I accept, and it is wonderful, and I believe.
And the man that lives there, right? The man in the moon.
Yes,
they have a man in the moon too.
Nice.
Watch it; it's really wonderful. I'm serious, and not even sarcastic, which is rare.
All right, we are out of here. Thank you very much,
Have a
everybody,
good
for
one.
coming on in, and we will see you tomorrow with. Are you coming tomorrow?
I don't know.
I mean, it's Ask Kathy Anything.
Oh, has it?
Yeah, it's not. That's if you come or not.
I've been upgraded, huh?
Yes. You're the new champion of that feature. I'd be afraid to give that one to John.
I don't
one
have,
question would be like 3 days long.
I don't have good enough
I tend to
answers
talk.
for stuff like that.
Blah, blah,
Chris says, "I hope she is."
Aww,
You have fans.
Thank you.
Chris is in Alabama.
Alabama?
Mm-hmm. He's the greatest chicken.
What?
If you know, you know.
I don't know.
Yeah, I'll explain.
If I don't know, I don't know.
John, thank you very much, John Filhaber, Kathy, and we'll see you tomorrow right here on SNSN. Goodbye.
See ya.
People say it all the time. I love to support local business. Look to a business that also supports the community in return. If you're looking for both of these qualifications, then Winton Automotive on North Main Street, Jewett City should be your choice for auto repair. Ken Winton is local, but